Hello, ladies and gentlemen, and welcome back. We're looking now at question number 5 on the 2004 grade 12 contest. It's the Euclid. So 5A, let's just dive in here. If 16 to the x is equal to 2 to the x plus 5 minus 2 to the x plus 4, determine the value of x. Alright. So with questions like this, the first thing that draws my eye is these 2's here. And I got 16. I know 16 is a power of 2, and I'm probably going to want to convert it so that I've got the same base everywhere. Because what you can do is if you can get on one side 2 to the something equals 2 to the another expression something, those two expressions have to be equal because you've got the same base. And this works if you had 3 to the something equals 3 to the something. But it doesn't quite work if you had 3 to the something equals 5 to the something. You can't just say, oh, these expressions have to be equal. The bases weren't equal. Okay, so I want to get a common base. I'm going to make it 2 just because it's easier and it will likely not introduce as many fractions. Okay, so let's get ourselves a brand new sheet of paper. So 16x, and then it was 2x plus 5 minus 2x plus 4. Now, I don't usually like subtraction or addition between exponents like this because it's not easy to deal with it. You divide between the two of them, you can take the difference of the top and bottom, not the top and bottom, you can take the difference of the exponents. But subtracting, addition, what I see is a lot of people do something like this, and that somehow you can do this. This is just garbage. It's utter rubbish. You can't just subtract the exponents. Inexperienced people treat it like multiplication and that sort of thing because they don't know what to do. And obviously doing something is better than doing nothing. And if you don't know what to do, you move on to another question and try and come back to it later. You don't just say, well, I think this is the way it should be, and so that's the way math is. I see university students do this a whole lot, especially when it's the last math class they ever have to take. So one thing I'm going to do, 16 is 2 to the 4. So I'm going to do that x there. And what we'll be able to do is, when it's written like this, an exponent law is that you can now make a product there. What I'm going to do over here is I'm going to take out a factor of 2 to the x plus 4. Okay? So that'll give me 2 to the x plus 5 minus x plus 4 minus 1. Now we got powers of 2 over here, so I suspect this should end up being a power of 2, and I think it'll actually end up just being 1. So x minus x, and then 5 minus 4 we get 1. So that's 2 minus 1 is just 1. And look at that, we have same base, different expressions. So 4x should be x plus 4. Bring one of the x's over to the other side. 3x is 4. X is going to be 4/3. If you wanted to, you could even double check, does this actually work? And you might say plug in x 16 to the 4/3 if you wanted to. If you grab your calculator, you might say 16 to the 4 over 3. And I get 40.31 something. I'm going to write that down here just for a second. You know, not really a nice number. I was expecting something maybe like 8 or something. But now we can do 2 to the power of 4/3 plus 5. And that's 80 point something or other. 80.634. And then 2 to the power of 4/3 plus 4 is again that 40.3174. And if we go back and take a look, if I took the difference of these, well, it's pretty clear that the top one is twice the bottom one. So we are just going to get 40.3174 again. So this did all work, and that's sort of the only way it could work. We couldn't be guessing and saying, oh, the one expression's got to be equal to 8 or 32 or 256 or something like that. The only way we could do this is really by rearranging and getting our x by comparing the exponents. Okay, but it's a nice, quick, short A part. I would guess maybe worth 3 marks, although I tend to get to lowball the light bulbs and overestimate the written, so maybe it was worth 4 or 5 or something. Okay, B part, that's what we're really here for. We're practicing our writing. In the diagram, the parabola with equation y equals x squared plus tx minus 2 intersects the x-axis at points P and Q, just as we've got shown here. Also, the line with equation y equals 3x plus 3, so that's probably going to be something we start with just because it has numbers, and this expression doesn't quite. We probably need to figure out t at some point. The line with equation 3x plus 3 intersects the parabola at P, so that's a common point right there, and R. I don't quite know where R should be, but I do know that P and Q are both on the x-axis, so they have a height of y equals 0. So if I plug y equals 0 into our line equation, I can probably figure out where P should be, and maybe from there figure out T. Anyways, what's the question actually asking us? Determine the value of T and the area of triangle PQR. Okay, now from the picture, if we just mentally dot in QR, this is going to be sort of a slanted triangle. Usually you like a right angle triangle for this sort of stuff, but really all we need to do is figure out the difference between P and Q. That'll be our base. And the height of R. It doesn't have to actually be over the base part. Just the height of R. So the y-coordinate of R should do just fine. And I think to do that, we'll have to get T on our way there, but we'll try and make the value of T a little more explicit, just because that's what they're asking for. They said, determine the value of T and the area of the triangle. So make a point, put a box around the answer for T, so it's quite clear. All right. So, I think we'll start out with this picture here. So our parabola sort of swoops down, and then he goes up. And then this line definitely goes through P. I guess this is 3 here, although I don't know if I'm going to use that. Q and P. So I'd say something like P is on x-axis. So has y-coordinate equal to 0. P is on the line. So 0 equals 3x plus 3. Minus 3 is 3x. X equals negative 1 is x-coordinate of P. Okay. So negative 1, 0 is P. I'm just going to add that in blue to our picture here. Negative 1, 0. Okay. I think that should be enough information to figure out what T is. So P is on the parabola. So negative 1, it was x squared minus T, I think. And I think it was plus 2. No, it would have to be minus 2 because it dips below the x-axis. So maybe it was plus Tx. But it's got to be equal to 0 because this is the y-coordinate of P and minus 1 is the x-coordinate. Let's just check. Plus T, plus Tx. Okay. So we get 1 minus T minus 2 is equal to 0. Bring the T over to the other side. 1 minus 2 is equal to T. T is equal to negative 1. And I would put a little box around that. Yay, we figured out what T is. And I would also say, so the parabola has equation x squared minus x minus 2 equals 0. Okay? So that's good. Or not equals 0, equals y. It was only 0 because P's y-coordinate was 0. I'm thinking quadratic equations and quadratic formulas and finding roots. We're going to have to find the other root Q in a moment, but we do need to have that y equals there, because then we're going to have to do stuff with R. Okay. So Q is the other root. X squared minus x minus 2 equals 0. I think we can probably factor that, especially because we know plus 1 is one of them. So it'll have to be x minus 2. Right? Because negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. I think we're all set. So Q has x coordinate equal to 2. I might even just sort of circle that one, or you could also say x equals negative 1 is for P. You know, that sort of stuff. If you want to extra explain your reasoning as to why you know Q has the y coordinate 2, I would say it's clear, but you might differ with me. You might want a bit more explanation. That's fine. So Q has a y coordinate 2. It's got to have x coordinate 0 since it's a root. So we'll deal with the triangle in a bit. I want to work out R now. R is on the parabola and the line. So we'll let R have coordinates x, y. The y coordinate obviously is equal to itself, but we can express that y coordinate from the line and from the parabola. And then what are we to do? Let's bring it all over onto one side. We'll get 0 equals, and we'll be able to sort of solve for that. We actually don't care what the x coordinate is. We really do just need the y coordinate. And the way we've got things set up, R could be over here. No, actually, no. What it is we'll have two different solutions, but one of them will be P and one of them will be R. Okay, I was thinking there might be some reflection. There isn't. We'll get x squared, and then negative x minus another 3x is minus 4x, and then negative 2 minus 3, that'll be negative 5. And we know x plus 1's got to be a root, and then that leaves x minus 5. And we might say something like, since x equals negative 1 gives P, x equals 5 must be x coordinate of R. So y is equal to maybe 3 times 5 plus 3, 18. Okay? Just going by their equation here, 3x plus 3. Plug in the 5 there. We can even mentally check 5 squared minus 5 is 20, minus 2 is 18 as well, so that really does work. We have factored things correctly and everything. So let's draw our picture again, but now we can go after that triangle. Parabola swoops down there, and then he's 5, 18 here, 2, 0 here, and minus 1, 0 here. Let's highlight our triangle. And to solve this guy, we can drop a perpendicular of height 18. So the y-coordinate of R is height of PQR, PQ, which has a distance of 2 minus negative 1, which is 3, is base. Area of PQR is 1/2 base times height. So 1/2, 3 times 18. The 1/2 and the 18 will cancel out. We get 3 and 9, 27. Okay? So that finishes that off. If you wanted to, because they asked for T and the area of PQR, yes, we put boxes around them already, but you might give a final little therefore statement of the value of T is minus 1. The area of triangle PQR is 27. Just leave it as 27. Some people want to put units squared, but really don't bother with that. We just care about the number, not what we're measuring in. Okay, so that sums it up and does give exactly what they asked for as a neat little summary. It makes it so people marking can just go to the bottom and say, did they get those right? Great. Instead of just sort of searching. So we've got another half of the contest to go, and it's going to be harder. These things do get harder. I'm planning to set aside, at least an hour for question 10, because that's the way it goes. But in the meantime, we've got question number 6. If you haven't given the contest a try question 6 before you move on and watch my video on that or look up their solutions, because practice makes perfect. Other than that, if you want to like, favorite, subscribe, all that stuff, but not that important. But either way, I'll see you guys for question number 6. Or if that's it for you, you say I tried question 6, there's no way I'm going to get it, and there's no way I'm going to get beyond that this year's contest. That's fine. I'll see you guys for another Euclid, or try the Hypatias or Galois. Those are written questions as well, but they're a little easier. Either way, whatever video I happen to see you at next, thanks for watching, and I'll see you there.